Okay. So just starting on number 1. You know, another thing I would do about you, just take account of the ones as we're going through that you look at and say, if I got that kind of problem, I know how to do that. You know, how many do you feel comfortable with? Remember, the cutoff is generally 27 out of the 50 that count. That's how many you need to pass. And you're going to add up, especially in these first 20 questions. Most of them you're going to say, I know how to do that, right? It won't be that much of a problem. So, and the only thing I'd add to this one, which we're all familiar with, we store a value. Generally, we store pi, right? And then we check the decimal values. Make sure you check the decimal values for all 4, right? Even if the first one gives you the right answer, it could be that one of them is actually just not as simplified as the other. And you may have to make a judgment call, which one looks more simple, right? So make sure you check the decimal values for each, right? And then pick the most simplified of them. And if it's in a fraction format, we know how to do the alpha y equals. We're good with that? So unless you slow me down, I'm going to keep going. Jaden, you're copying? Okay. A lot of them will have the same notes next to them, right? Like the number 2, operations with imaginary numbers. You know where to find the I on the calculator? Right? It's above the decimal point. And if you're doing any kind of operation just like this, then you just enter it away. You don't even need to be in the mode of A plus BI. It'll work, right? Just enter it exactly like you see it. You know, be careful with what's a negative and what's a minus, right? Because if you're just making an error with a calculator, I can't really help you out on that during the test. Right? Here's another one, right, of factoring. I mean, the truth is that the most difficult problems are generally rational expressions, like the first one, radical expressions, and factoring. Most of those are dealt with in a multiple choice format in a way that you'll get them right. I'm pretty confident you're going to get those right. You know, it's not bad to understand that this is a difference of cubes, and we would expect that at the very least it's going to be a binomial times a trinomial. So I don't even need to check these two. I mean, that's using a little bit of algebra and then just checking the ones that I've got to check. Right, this 4 and 5 are checking a radical, checking a rational. It's all the same. I mean, I would hope that out of those first 5, that everybody in here is 5 for 5 heading into number 6. No reason why we're not 5 for 5 heading into the next one. And in fact, 6 for 6. Now, how do you find the 4th root symbol? Where is that in the calculator? Math 5. Okay. If you don't put a number in there first, if I just go math 5. You know, it says answer, and you're going to have to scroll up over there and replace it with a 4. You could also just, before you go there, put a 4 and then do math 5, and then it puts it in the right spot. Okay, this is one doesn't even have variables, right? So you just put it in, see which one equals this. Now we get to our first not multiple choice question, which was a simplify a radical. And again, we have steps for simplifying a radical, right? This is a cubed root. So you would look at that 162 and say, is it a perfect cube? Okay, well, if you don't know your perfect cubes, then how do you make a list of the perfect cubes? So you could check it against that. Remember, in the calculator, on the y equals, put x to the 3rd. And then in the table of values, that's your list of the perfect cubes. So you just look at that. Is 162 in that list? No. So you say, well, are any of these factors of 162? And start with the number, the biggest one that's less than 162, and start dividing until you find one, which does divide into equally, and it's actually 27, right? So you divide 27. So it would be 27 times 6. And then the third root of x to the 6th, can you take out all the x's? Yes, right. 6 divided by 3 goes 2 times. Now, y to the 7th, you can't take them all out, so you split it up between a y to the 6th times a y, and simplify what you can, and some will be left out. I mean, if you're given in this format, there is a little bit of like guess and check you could have done, right? You could always drag a few into that block and drag a few into that block, and then do the store value for the variable and see if your answer equals that answer, you know. This is back to another one where you can store for the variables and check. Okay, here's one. It's a factoring problem. We know that 2 of these multiply together to give you that polynomial. And, you know, again, you can just guess and check a little bit. I mean, you would know, for example, that it can't be the first 2 because that would be x times 2x, which is not 8x squared. It's only 2x squared, right? If the first one starts with an x, then the other one's got to start with an 8x, so that you get 8x squared. So you could try those 2. Foil them. Does it work? The other thing, you know, just go down and, you know, if the first one's this one, 2x minus 5y, then the other one's got to start with a 4x. So, you know, just try it out. It turns out those are the right 2. So this one times this one, you know, you could foil it. You could store values for x and y and see if that equals that. I mean, you have options. But obviously, that's not a multiple choice kind of thing. This one, you just got to know the properties. And my guess is that we don't. And there's probably no amount of us, you know, we're not going to put in a ton of work in between now and then to memorize a bunch of properties that we've been hearing about for many, many years now. You could go, you know, pages 14 and 26, they have all these properties there if you wanted to review them. I doubt there's more than one question on the test that is that, right? So, I mean, I wouldn't knock myself out on properties at the expense of all the other things that are on the test. Okay, how do we do the I raised to a power? Remember, you go math num 3. Math num 3. It's called I part. Just do it inside those parentheses and see which one equals, in this case, I. Okay, don't use the I part if you're just doing operations with imaginary numbers. I've seen it be wrong. And I think it's like I don't really understand how the I part works. If all you're dealing with is the I part of it, it'll work. Not if you got anything else in there. You know, I know that on our readiness tests that we did, there was a fair amount of people that were writing down 2e negative 13 plus I, you know, that's the thing we're trying to avoid. You know, you don't want to get that scientific notation, e to the negative. That I part clears that up, and you won't have that problem. I mean, if you know that, then I'm sure you're going to get that kind of problem right. Right, absolutely sure. This is another one you can store. Now, can you put fractions inside of fractions using that fraction format? Yeah, you absolutely can. Okay. If you get really complicated expressions like that, remember you could, you know, I'd just call it chunk it. You know, you could do the top and do the bottom separately and then divide them, you know, if it's too much to do all at once. But it's still the same process. See, that gets us up to number 13. My bet is we're up to about 9 of them for sure that we're getting right up to that point. Okay, now we get into the equations in a multiple choice format. Right? In a multiple choice format, you could always just plug in and see which ones work. Right? And you can do that the hard way, you know, by saying 8 times 67 over 8 minus 1 inside of a square root, you know. Or you could store 67 over 8, store x, enter. And then put that expression in and see what you get. Right? If it doesn't work, then try that one. You know, I think it'll save you making mistakes, especially when there's negatives involved and raising to powers. Sometimes we don't do well with that. But if you type the expression in and you've correctly stored for the variable, you won't have those kind of order of operations or powers of negative numbers. Now, there is one other thing that we can do, which these are mostly the slides that I used last year. I couldn't find until this morning. I just found them. There's one thing that I've been emphasizing a little bit more this year, which is, you could always solve this like a system. You could put on line 1, you can put the left-hand side of that equation, right? And on line 2, you could put the right-hand side and then look for where they intersect. Look for the x values where they intersect. Remember, you don't care about the y values. You introduced the y values when you did that. There were no y values in there. But if you just draw this graph and see where it crosses that graph, that's going to be your solutions right there. Okay, remember, if you've got to do an absolute value inequality, 2 variables, right? This has got both an x and a y in it, right? You're going to put it on that line. You got to remember, where do you find absolute value? And where do you find absolute value? You can do math num1. You can do alpha window 1. I think you can do second 0 for the catalog, and it comes up. There's many places. Make sure you know how to get to one of the absolute values, right? This equals right there. You're not going to change that equal sign. What you're going to do is you're going to go all the way into the left margin and then hit enter until, for this one, because it was a greater than, you're going to make it that upper right triangle. And when you do that, you're going to get a graph that's got the line in the right place and the shading in the right place. Now, the one thing it's not going to tell you is whether or not that line should have been solid or dashed. That we won't know. Remember, if it's or equal to, it's solid. If it's not or equal to, it's dashed. Right? So math num1 for the absolute value, and then you enter. This one is, I think, about the third enter. You get that, maybe the second enter. If it's a less than, you go one more and look for the lower left triangle. Right? This is a quadratic formula. Right? You're just going to have to know how to do quadratic formula, which is given to you on the test, on the formula sheet, right? Remember, the quadratic formula is the only method that always works for a quadratic equation, and it's given to you. So you just have to know how to use it. And what was I going to say? Remember, what do you have to do to a problem like this, though, before you use quadratic formula? Everything's got to be on one side, 0 on the other. It's got to be standard form equals 0. I mean, the formula sheet actually shows that, right? It says ax squared plus bx plus c equals 0, and then there's the quadratic formula. Okay, here's another one that you can either plug in. Either way you plug it in, you could solve it as a system, right? Make the left-hand side line 1, make the right-hand side line 2, look for where they cross. Right? What are the steps again when we do that? Once you've got them on line 1 and line 2, you do second trace 5, right? Now, what's the difference between this one and this one? There's no y in that, right? There's no y. It's a one variable absolute value. So you're still going to, if you do it with the calculator, you're still going to put it on line 1 there. Just, you're not going into the margin for your less than or greater than. Instead, you go to math, or sorry, I don't even have that in there. Second, math, right? Second math is the test menu, and that gives you all your inequality symbols that you put in there. And when you do it, you're going to get something that looks like that. And hopefully you can, from that, back out what the inequality was. Okay, look for the solutions. Where do you look for solutions for a polynomial? X-intercepts. And that's the algebra kind of knowledge. You have to know that part. And again, here's another system, right? If you're going to solve it using the calculator and graphing, you're going to solve for y first, right? And then you're going to graph it. And in this case, there was 2 intersection points. And you find them, again, by doing second trace 5. Usually, it'll just be enter, 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 right? Okay, where do we look for the solutions in a system? Are they the x-intercepts? Are they the y-intercepts? It's the intersection points of the 2 graphs, right? So these 2 cross here and here. So if it's a, like this problem, it was a click with your mouse. Done. Okay. Now we're getting into a rational equation, right? In the rational equation, you could still plug in, as long as you're all right with, there's a lot of plugging in, a lot of formatting if you're going to use the fraction format. Again, personally, I would probably store, especially when I get into these fractions, negative 27 divided by 4, store x. And then put this in the calculator and put that in and see if you get the same thing. Okay. And then what is the solution? This one, I would say absolute value equations in some ways might be a little harder. Now, if it's a multiple choice format, you can definitely just plug in. But it's harder to put it in and find the solution just by looking at what's on the calculator. Because if it's a fraction, it's not going to show up in the table of values. Remember that to actually solve an absolute value equation, you isolate the absolute value, and then you turn it into 2 equations. What are the 2 equations in this problem? 2x minus 7 equals 8. 2x minus 7 equals negative 8. Right? Set what's inside equal to the positive and the negative right-hand side. Solve. You get 2 answers. Right. Again, this is another one that you would have to, it's not a multiple choice format. You're going to have to solve it one way or the other. If you were going to solve it, you would multiply by the least common denominator, which in this case is x, and then solve what's left. You could also solve it as a system, right? Put that on line 1, put that on line 2, and look for the intersection point, right? You'd only care about the x values. In this case, it was 6. Right? Here's another K for knowledge, right? K for knowledge, right? If you know one solution to a quadratic has got a square root or an I in it, there's got to be a pair that is exactly the same thing except for that sign is switched. It's called a conjugate. So if 13 minus 11I root 7 is a solution, then so is 13 plus. There's nothing else to do. There's no point putting it in the calculator. You just got to know it. And if you do, it's a half a second, and you got it. That's definitely one is worth trying to somehow drill into your brain because it's an easy question. Doesn't require much work. We've seen the last 2 release tests that they give us. They both had a question just like that. Caitlin? Okay. Right? You got to know about domain and range, right? This is a function. These are functions. They're saying which one of these does not have a range of only real numbers greater than or equal to 0. If you put these in the calculator, you would have gotten these 4 graphs. And if you know what range is and what you're looking for on a graph, these 3 should definitely look like they started at y equals 0 and they went up from there. That's That is all real numbers greater than or equal to 0. The only one that's not is the logarithm. And remember, logarithm has got an asymptote here, and the graph approaches that and gets infinitely close as it goes down to negative infinity. Definitely not starting in the middle and only going up from there. Although if you put it in your calculator, you might get that effect like we saw before, where it does kind of cut off about right there. So you got to know logarithms. Okay, this is a infinite series. We just did one like that, but formula sheet. Right? We should know how to use the formula sheet for that. Okay. Which one of these looks like that? Well, you put them in the calculator, see which one has this shape that looks the same, right? This is the shape of A, B, C, and none of them look like that. And then that's the shape of that. Inverse variation. Right. Which number is a 0 of log 4x minus 1? Again, you got to know what's a 0. A 0 means what's the x-intercept? What's the value of x that makes y equal 0? Right. And, you know, it might be useful to, know how to use the calculator to find zeros. I mean, it has a particular option in the menu here. There. Watch. Log of 4x minus 1. Log. I keep doing that. 4x minus 1. Okay, if you look at that, you may not think it has a 0. If you zoom in, you'll see the 0, right? Zoom to. Enter. Okay, it definitely goes through the x-axis. Yeah, now, the calculator in the same menu that we use for intersection, second trace, there's 0. I mean, it has a function just for that. So definitely hit 0. And when it says left bound, it's asking you for an x value which is less than or to the left of where you see the 0. And at this point, if I hit enter, it doesn't work. It's not going to work because it's actually not on any graph right now. What we would have to do is second trace 2. Arrow over so that you're actually there we go. So you can see it. It's on the graph. It's a little bit, since it's going like that, it's down and to the left. Enter. When you get it up and to the right, there's got to be a 0 in the middle. And guess. 0.5. Now, you can find any 0 that way, any 0. Okay, we already talked about this one today. Again, it's more of a knowledge question. You've got to know that exponentials have a graph that look like that. Exponential growth looks like that. It has an asymptote, which is on the x-axis. Right? This minus 5, which is in the function, is shifting to the right 5, but that's not going to move the graph. The minus 4 is going to move the whole graph down 4.
Hey, do we have any makeup on for Vic?
No, we're taking a test. Okay. You too?
Huh? Oh, no.
Oh, okay. 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 So we got to get straight on these transformations here. Okay, which function probably represents this? They're not trying to confuse you with different kinds of functions. They're all the same kind of function. They're just trying to say which one of these shifts looks like it made that graph. And what does it look like change? It looks like the whole graph is down 4. So how do you make a graph go down 4? You subtract 4 at the end of it. Now you could put it all 4 in the calculator and look, see which one looked right. Okay, this one, confusing because of the 2 there. In the end, it's not shifting the graph up, down, left, or right. We know the graph then has an asymptote here. It has no y-intercept. It never touches the y-axis, and it clearly crosses the x-axis once. That's the answer. Right. Increasing and decreasing, if you're going to graph it, right, look for the x values where the graph looks like it's going down. In this case, 2 to 4. Again, logarithm, inverse of an exponential, right, has a graph that looks like this. Right, what's that minus 16 doing to the graph? Inside the function means to the right, okay? If you move this whole graph to the right, it's going to move that vertical line to the right, okay? So which one of these represents the asymptote moves 16 to the right? X equals 16. It's a vertical line, so it's x equals, right? 15 up and down doesn't change anything, right? It doesn't change the asymptote, right? Looking at this graph, okay, the only y values are 1, 2, 3, and 4. Now this notation, you know, we shouldn't be confused with because we've seen it in their release tests. I mean, these are called set brackets, and you read it like this. You say, the set of all y such that, that's what this bar is, y equals 1, 2, 3, 4. 1, 2, 3, 4. Okay, a normal curve, second bar is 2, lower, upper, mu, sigma. We know how to do that, right? Permutations and combinations, we know where to find them in the calculator. When do we use permutation and when do we use combination? Permutation is when order is important, right? Right, sequence and series, formula sheet. Inverse functions, right? An inverse, if this is the function, remember the inverse should have the same, should look like it's got the x's and y's switched around. So just take a couple points, like the y-intercept is 0, 2 here, then this graph should have an x-intercept of 2, 0, which is that. Right, the x-intercept was 4, 0, this one should have a y-intercept of 0, 4. Just take a few points, switch the x and the y. Okay, this one I think you'd probably put in the calculator, right? You know what to look for on that. Yeah, I think it's probably better I don't say anything more. I mean, this is the end behavior, and end behavior could mean a couple different things. But, you know, in this problem, definitely it's a parabola that opens down, which means as x approaches negative infinity and positive infinity, it's approaching negative infinity in the y direction. It could be more like a horizontal asymptote to a rational function, but it's not really. Okay, this is, we just went over this in the other package, about a composition of functions, right? Since the f is inside the g, you take the f and you put it inside the g, right? And then you simplify. And if you have a hard time simplifying, like there's foiling involved and things like that, you can always store a value for the variable and then see which one of these got the same decimal answer. Now, I think this next one is more of, it's really a knowledge question. I'm not sure how else we would come up with this. The domain of this rational function is all real numbers except it's the zeros of the denominator, because if it's a 0 at the denominator, it's going to lead to a divide by 0. Now, how else might you do that with the calculator? I think actually some of you probably do this successfully. You know, if in this one, it would work. If you put that in the calculator, y equals, and go to the table of values, see which one, at which x values it says error or undefined. Those will be the exceptions. And because both of these are integers, they're going to show up in that table of values, right? Just look at scroll down the list, find the values for which it's not defined. Okay, I mean, this is variation. So you got to just know it. There's nothing. We have no tricks for this. Not on the formula sheet. You got to know direct, inverse, joint. Scatter plots, stat edit. Put the x and y values under L1 and L2. Stat calc, and this one was exponential, so use the exponential. And in this case, it wasn't asking you for the equation. It was asking you to make a prediction. Once you've got the equation, plug in 30 and see what you got. Right? Zeros. Again, zeros are x-intercepts. So which ones of these have x-intercepts at -2, -1, and 2? -2, -1, and 2. Permutation, we know how to do that. We know where it is in the menu. Again, another variations question. And the last one, you know, when it's asking you the questions in a, you know, how many and what kind of solutions do you get, or roots for a quadratic, you could think of it like a quadratic formula. This got erased. You could think of it like a quadratic formula. Remember that in the quadratic formula, this part right here is called the discriminant. If the discriminant equals 0 in this problem, that means that when you do plus or minus the square root of 0, you get the same thing. It's one real number and occurs twice. So it only has one real root, and it occurs twice because of the plus or minus. If this number is greater than 0, you would get 2 real roots. If this number is less than 0, now you're taking the square root of a negative, you get 2 imaginary roots. When do you get 1 imaginary root? Never. Right? Never. They always occur in pairs. You're never going to get that. Okay. I had in mind to do some other things, but I think we've done all we're going to do for today. I'm going to say that for homework, if you can, right, you should go to the Jefferson Labs website. I mean, is there anything you can do to practice? Right? It would, to me, go here. It's plenty good. It's got all these questions that we're looking at in that package we were working on before. Most of the things we got, they're kind of recycling these. And if I go to, again, you can Google. I mean, if I haven't already sent a link, I'll do it again. You just go Jefferson Lab SOL, and it brings up this page right here. And here's your Algebra 2. It's set to 20, that's fine. If you just accept it as it is, it's going to give you, you know, everything. These are all the different options that are in there to be set, right? The first thing when it asks for which to use, I would just keep with what they've got. Right? These are checked. This one, use the realigned strands. That means with the new SOL, right? Since 3 years ago. Use all years. But when it comes to this screen right here, honestly, I think I would be concentrating on functions and statistics. I think that the expressions and operations, those are the things that are at the beginning, all the rational and radical and factoring kind of stuff that I think you're going to get, you know, by one way or other, you're going to get those. These are the more questions that are like knowledge questions that you need to get. Functions and statistics. It also includes the variations, sequence and series, normal. It's all in that category right there. So I would click on that. right? And then when it offers you this, do you want just a random pick or a fixed set? I would choose the fixed set. I've looked at the first fixed set, number 1, and it's pretty good. And at least if we all did the same one, then we could all, go over it together too. And I could bring it up and we could see what we looked at. Now, when you're doing this kind of problem, right, if I give an answer, and it's wrong, there's an explanation right there. So you can scroll down and read their explanation for why it was wrong. So I would be doing that. What else was I going to say? I think most of you are going to be here next time. Hunter is not going to be here, and Gabby is not going to be here. Is there anybody else have chemistry SOL that I missed? Just you two, right? What's that? Yeah, it's in the morning. We don't meet again until Friday in the last block of the day, like 1:50 or whatever it is. So you two are the only ones. I mean, I hope you can come in sometime before school, after school, whatever. Maybe at the very least, like next Tuesday and Wednesday. We test on Wednesday. Monday's a holiday. We test on Wednesday. Come on in and let's just make sure you know how you would attack each individual kind of problem. And if I don't see you before then, just be patient. It's a long test. There's probably 60 questions, but 10 don't count, and you don't know which 10 they are, right? But you need to get 27 out of the 50 that count right. So you don't need to, if you look at a few in a row, say, I didn't know how to get any of those. Don't worry. I mean, you can get a few in a row wrong on this test and still do fine. So do you guys have any questions for me? So we've got another 15 minutes or so. If you have your cell phone, how many have an Android phone? Anybody? If you got the Android phone, that you can get that calculator emulator, Wabbit EMU, and then you've got an 84 in your hand, right? So also, you could do the Jefferson Lab website on there or whatever. Just make sure you put in a little effort. Okay. Yeah. Not right now. I'll let you go a few minutes early. They told us. Did you hear their announcement? Did you hear the announcement today? Okay. So I'm gonna add this on the recording here. Homework